Hello, Born-Hilborn vs. Pilot wave theory. Why hidden trajectories do not explain reality. Pilot wave theory, also called de Broglie-Bohm theory or Bohmian mechanics, begins with an attractive promise. Maybe quantum particles are not truly indefinite. Maybe an electron always has a definite position. Maybe it travels along a real path, guided by a wave. Maybe the weirdness of quantum mechanics can be rescued by saying, do not worry, the particle was always somewhere. We simply did not know where. That sounds comforting. It also sounds suspiciously like classical physics, wearing a quantum costume. So they're saying quantum is not real. For the folks whose minds are too timid to process more modern physics and its applied mathematics. Pilot wave theory says that particles possess definite positions at all times and are guided by a wave function evolving according to Schrodinger's equation. The theory is deterministic, realistic, and explicitly non-local. The behavior of one particle can depend on the configuration of the whole system. Everything is dominoes in that. So the pilot wave story is this. The particle is a little bead. The wave is a guiding ocean, and the bead surfs the wave. It's charming, a visual, very satisfying to people who miss billiard balls. But the problem is that quantum mechanics did not become strange because physicists forgot how to draw a little pass. It became strange because of paradoxes and things that we cannot explain with class physics. It became strange because every attempt to force classical style pass back in the system creates new conceptual debt, more paradox than resolution. Pilot wave theory does not remove the weirdness, it hides the weirdness inside an invisible guiding wave. An hidden initial configuration and non-local machinery. It says the particle really had a path, but you cannot directly know that path without disturbing the system. So it gives you a path you cannot simply measure, guided by a wave that must encode the whole experimental arrangement, including distant conditions. This is clinging to determinism. The Born-Hilborn interpretation begins with a different insight. That core problem is not that particles lack cute little tracks. The core problem is that quantum measurement selects reality. And if measurement selects reality, then it selects not only the outcome, but a whole compatible history to that reality. That is the decisive difference. Pilot wave theory wants trajectories. Born-Hilborn wants history selection. And history selection is the deeper issue in quantum mechanics. When Schrodinger's cat is observed alive, the selected reality requires an entire living cat history. In Schrodinger's cat, when the cat is observed dead, the selected quality requires an entire death history. The important question is not which path did the particle secretly take. The important question is which complete history became real. Pilot wave theory answers the smaller question. Born-Hilborn answers the larger question. Pilot wave says the particle had a definite path all along. Born-Hilborn says the world selects a coherent history under quantum possibility multiplied by expectation across spacetime. That is why Born-Hilborn is more explanatory. The equation is simple. Reality equals the Born rule multiplied by expectations across spacetime, including the future. Or shorter, reality equals QM times spacetime expectation. The Born rule supplies quantum possibility. The Hilborn rule supplies expectation weight. Collapse is not random outcome selection. Collapse is history selection. Pilot wave theory avoids collapse. It says the wave function does not collapse at the fundamental level. Measurement is just another physical interaction. The particle always had a position, and the guiding equation always directed its motion. That sounds clean until you notice the missing pressure. If there's no real collapse, then there is no history selection. If there's no history selection, then there is no mechanism by which expectation weights possible histories. Pilot wave theory may give the particle a path, but it does not give reality a reason to select the one world we know and love through expectation. That's still dice rolls according to Bohmian mechanics. And we're going to talk about the Bohmian mechanics in a minute. It does not give us a selected history. This is why pilot wave theory is ultimately too small. It tries to solve quantum weirdness by restoring particle paths, but the mystery of reality is not solved by drawing a line behind an electron. The mystery is why this whole world history becomes definite. This cat, we have to draw the line behind the cat. This observer, this memory, this body, this sex drive, this biological ancestry, this future, this past. Reality is a whole structure. We collapse every time we open our eyes, because when your eyes are closed, the entire universe is inside Schrodinger's box. Poof. That's our global consistency, is because every loci of comparison contributes to this collapse. A little hidden trajectory cannot carry that burden. Now let's talk about the famous weak measurement claims associated with Ephraim Steinberg's group. In 2011, Kosis, Braverman, Ravitz, Sham, Steinberg, and collaborators published work titled Observing the Average Trajectories of Single Photons in a Two-Slit Interferometer. The title itself is important. Average trajectories. Not the literally filmed path of one individual photon like a marble on a table. They didn't follow anything. The word average does all of the work. Weak measurement is a technique that extracts very little information from each system while disturbing it less than a strong measurement. But because each individual weak measurement gives very little information, one reconstructs meaningful results by averaging over many similar prepared systems. They've never tracked an electron all the way through. So when someone says we track photon trajectories, they carefully translate as, no, they're lying. They reconstructed average flow-like paths from many weak measurements on the ensemble of similarly prepared photons. That is not the same as putting a GPS tracker on one photon and watching it politely take a lane through the double slit. You cannot track an electron or photon in the ordinary classical sense without making measurement part of the phenomena. Measurement is not neutral camera outside the universe. Measurement changes the quantum context. Weak measurement reduces disturbance, but it does not magically turn quantum objects into classical alive cats sleeping across graph paper. The experiment is a clever way to bring determinism back. The interpretation is the problem. Even summaries sympathetic to the work describe it as tracking average paths using weak measurement and ensemble averaging, not directly watching one's particle's private classical journey. There's a crucial distinction. It's not the same at all. Average reconstructed trajectories are not proof that a single photon had a classical little path in the way naive pilot wave storytelling invites the public to imagine. They're operating reconstructions from weak values in post-selection. They are not a divine surveillance tape of the particle's secret life. It's all BS. This is why Born-Hilborn is more careful. It does not need to pretend that the electron was a tiny billiard ball all along. It says quantum possibilities exist as possible histories, and measurement selects the coherent history. The history is not discovered like a lost coin under the couch. The history is selected and only appears like a billiard ball. Billiard still works in this model. Pilot wave theory says the path was always there. Born-Hilborn says the selected history becomes definite. This is a more powerful claim because it addresses the true implication of the measurement. The Steinberg-related surreal trajectory debate makes the pilot wave problem even worse. Bohmian trajectories can look bizarre compared to the ordinary classical intuition. In the ESSW-style objection, a particle can be said in Bohmian terms to have gone one way, while a witch path detector indicates the other way. This led critics to call such paths surreal. Later experiments from Steinberg's group argued that the apparent surrealism can be explained by Bohmian non-locality. A report quotes Steinberg saying, "The ESSW argument damaged my love for Bohmian mechanics," before later results revived his interest. So think about that. If your theory needs non-local rescue operations to explain why the particle's real path can disagree with the particle's apparent path, maybe the public should stop being told this is a simple return to common sense. The whole selling point of pilot wave theory is that it gives us clear trajectories. Then the trajectories become so strange that they are called surreal, that the defense is that they only become surreal because of non-locality, which that is not common sense. That is quantum weirdness dressed up to mock determinism. Pilot wave theory says the particle path is real, but when the path gets weird, it says the wave and the total configuration explain the weirdness non-locally. Fine. Now we're no longer enjoying the simple classical picture. We're dealing with a non-local hidden variable ontology whose supposedly clarity vanishes exactly when the experiment becomes interesting. Born-Hilborn does not need this detour. Born-Hilborn says the particle's so-called path is not the deepest thing. The selected history is the deepest thing. Measurement does not uncover a tiny pre-existing trail. Measurement helps select a coherent space-time history for those particles. That is why Born-Hilborn can absorb retrocausality, teleology, thought, memory, and observer weight without pretending the universe is secretly a Newtonian clock with an invisible quantum pilot. Another problem with pilot wave theory is that it reproduces the predictions of ordinary quantum mechanics under quantum equilibrium. That is not a small detail. It means pilot wave theory often gives the same empirical predictions as standard quantum mechanics, while adding a hidden ontology underneath. Bohmian mechanics is designed so observers see the usual quantum probabilities. It's designed so that you see that wave pattern. So we should ask the rude but necessary question, what is being gained if we're mocking it? If the hidden variables cannot be directly observed without breaking the theory's empirical agreement, and if theory must remain non-local, and if its trajectories become strange enough to be called surreal, then we have not explained reality, we have relocated the mystery. We have just playing dress up. We have taken quantum awareness out of the living room and stuffed it into the basement, leaving room for the more satisfying history selection model. There is also a deeper conceptual issue. Pilot wave theory treats the wave function as a guiding structure and the particle configuration as the actual physical arrangement, but for many particle systems, the wave function lives in configuration space, not ordinary three-dimensional space in the naive wave biologists imagine. That means a simple visual metaphor of a little wave pushing a little particle is dangerously misleading. It's the true mathematical object is not a wave rippling through ordinary room space like a water in your bathtub. The cartoon is comforting, but the mathematics is stranger. Pilot wave theory says there is one actual configuration guided by a wave function, but the guiding wave contains information about the whole arrangement. The little particle is not simply being pushed by a local ripple, it is guided by a structure whose behavior depends on that full configuration. That is why the theory is explicitly non-local. Pilot wave theory sells you a picture of a boat on a wave, then quietly replaces the ocean with a higher dimensional mathematical ghost ocean that knows what's going on in every river. That is not a satisfying foundation for consciousness, memory, sex drive, or teleological creationism that the Born-Hilborn interpretation handles. Born-Hilborn says the missing piece is not a hidden trajectory. The missing piece is expectation-weighted history selection. History selection is how we must view quantum mechanics to understand all of reality. This is the solution. Weighted history collapse. Weighted observer collapse. WOC. Now consider the electron. If someone says we can track the electron, ask by what measurement? A strong measurement changes the system and destroys context. The weak measurement gives tiny partial information and requires this averaging. Either way, measurement is part of the event. There's no innocent little camera outside quantum reality. The claim that one has observed the trajectory should therefore be treated carefully and as a lie. In the weak measurement context, it has been observed as is an ensemble level reconstruction under a particle measurement protocol based on averages. That is useful physics. This is not proof that nature is secretly classical. You're just watching history we have selected from a future moment of linear time perception in a simultaneous block universe. Born-Hilborn takes the measurement problem more seriously. Measurement is not a passive reading of hidden furniture. Measurement is participation in history selection. The observer state, expectation, memory, and future boundary conditions matter because the selected result requires a selected past. This is where pilot wave theory becomes moot. It removes the observer from the foundation and treats quantum theory as a quantum theory without observers, to use the standard framing of Bohmian mechanics. But consciousness is precisely what any adequate interpretation must eventually explain. A theory of reality that proudly removes observers from the fundamental story may be useful for particle bookkeeping, but it cannot explain the observer experiences central to the world we can actually know. It cannot resolve paradoxes such as Frobisher-Renner. It can calculate outcomes. It cannot explain why thought has weight. Born-Hilborn says thought is not an accidental steam cloud above neural machinery. Thought is expectation pressure within space-time. Expectation participates in selecting history. All of space-time thoughts matter for every collapse. Consciousness is not outside physics. Consciousness is part of the weighting rule. Pilot wave theory says particles have definite locations at all times. Born-Hilborn says minds help select definite histories. Which one explains more? Memory also exposes the weakness of pilot wave thinking. Pilot wave theory can say the brain particles have definite Bohmian positions. Wonderful. Does that explain memory? No. It merely says the brain has an actual configuration guided by the wave function, but memory is not explained by saying atoms had positions. That is a category error. Biology assumes that the brains must contain memory, but we've had more viable and reliable alternatives to brain memory since 1905. Born-Hilborn gives memory a deeper place. Memory is the present observer state relation to selected history. It's CPT comparison ledger symmetry. If collapse selects the coherent past, then memory is not merely a local file stored in meat. It is access to the space-time ledger of the selected history. The brain is the interface, not the warehouse. An ape is forced to believe the singer lives in the radio. The pilot wave model gives you particle paths. The Born-Hilborn model gives you memory as history relation. That is a more complete ontology. Now we can talk about teleology or intelligent design. Yes, I said intelligent design in a science video and math video. Pilot wave theory is deterministic, but deterministic does not mean purposeful. A deterministic mechanism can still be blind. A marble rolling down a track may seem deterministic. It does not seem teleological. Pilot wave theory gives particles definite trajectories, but it does not explain why biological history should produce breathing, sex drive, thumbs, consciousness, or future-oriented meaning. Born-Hilborn does, because Born-Hilborn includes expectation across space-time. The future can contribute weight to the selection of past compatible histories. The future breathing organism weights the histories in which gas exchange, plants, atmosphere, oxygen, and lungs become possible. The future hand weights histories involving grip, claws, manipulation, and thumbs. The future child weights history in which ancestors reproduced that child. We have to have babies because future humans expect to exist in this mathematics. This explains why time seems to move forward in a forward direction. This equation explains time. Reality equals QM times space-time expectation explains why time moves forward and not backwards. History selection via constant collapse explains our concepts of time more satisfactory than other definitions. Pilot wave theory says the particles move where the pilot wave guided them. Born-Hilborn says the whole history was selected under future-weighted expectation. One theory gives motion, the other gives meaning. This is why my crab example matters. You're learning to grab. You're collapsing a reality where we learned thumbs personally. I had to live as a crab to learn my thumbs. A pilot wave account can describe the particles in a crab claw as having definite positions. How impressive! Our expected thumbs still remain a biological fact, requiring an evolutionary history. Pilot wave does not explain why thumbs appear as a recurring function across life. It does not explain why future thumb or gripping manipulation would matter. It does not explain why thumbs become the later refinement of gripping histories. Now we drive fancy bipedal human avatars all shiny. Born-Hilborn says future thumbs expectation weights earlier grip history. Crabs are not humans, but crab claws are functional rehearsals of grasping. Crabs are people in training. The claw is a primitive thumb equation in biological possibility space. A human is a god to the crab, learning to grab in this model. We personally must live as crabs to intelligently design our own thumbs. That is teleological creationism through history selection. We practice. We put ourselves together like Frankenstein and his monster. Pilot wave theory cannot reach that level because it is obsessed with the particle having a path and being deterministic the entire route. But reality is not merely a set of particles with past. Reality is a selected history with direction, memory, consciousness, and expectation. A dreamscape for anyone not familiar with this idealism mathematics on your screen. This is an idealism interpretation of quantum mechanics, where with external memory and where death would be a waking up process. The plant example is the same. Pilot wave theory can describe particles in the leaf. It cannot explain why plant life functions as respiratory preparation for future breathing organisms. Born-Hilborn can. Future breathing in eyesight waits earlier gas and light exchange histories. Plants become part of the selected ancestry of lungs and eyesight. Born-Hilborn gives us intelligent design without the cartoon supernatural engineering. No gods with grey beards hurling lightning bolts. Not always. Sex drive is another example. Pilot wave theory can say biological particles move deterministically, but that does not explain why the future person seems to pull ancestral history into existence. Born-Hilborn says future observers weight the reproductive histories that create them. Sex drive is biology plus future weighted history selection. The future demands its own past. Pilot wave theory does not have the machinery for this. It has guiding wave, not future expectation. It has hidden variables, not history selection. It has trajectories, not teleology. Pilot wave interpretation is a biology religion. Determinism is the fantasy of Pinocchio, hoping to be a real boy. But there are no blue fairies to make that possible for them. Born-Hilborn interpretation is more satisfying. Pilot wave theory also struggles rhetorically because its hidden variables must remain hidden in a very special way. If the underlying variables could be directly exploited, one would threaten the no-signal structure of quantum mechanics and invite faster-than-light signaling paradoxes. Summaries of the debate note that the hidden variables must be, in practice, unobservable for the theory to preserve standard predictions. Better not look anywhere else for reality, nudge, wink, say no more. So the pilot wave advocate says the particle really has a path. Then says, but you cannot directly know it. Then says, weak measurement reconstructs averages. Then say the trajectories may look surreal. Then says non-locality saves them. Then says the predictions match standard quantum mechanics anyways. At some point, one is allowed to ask whether the real path has become explanatory theater. Born-Hilborn does not need hidden theatrical machinery. It gives a direct interpretive upgrade. Reality equals the Born rule multiplied by space-time expectations. That is not a past story. That is the history selection rule. That is the golden rule. The Born rule gives the standard quantum weights. The Hilborn rule adds expectation across space-time block, even the future. That is the move. That is the key move. Measurement selects a coherent history. This explains why the past becomes definite with the present. This is my mathematics. Reality equals QM times space-time expectations. That is the addition that I have added. I am Hilborn. This is why future expectations can matter. Why thought has weight. Why memory attaches to history. Why biological functions can appear teleological. And why we experience one world that we know and love rather than an unresolved field of alternatives. Pilot wave theory tries to make quantum mechanics less random by making it deterministic. Born-Hilborn makes quantum mechanics more meaningful by making collapse a weighted selection of history. Those are not the same ontology. Determinism alone is not enough. A deterministic universe can still be meaningless machinery. Born-Hilborn gives direction. It says future expectation weights past compatible histories. It turns collapse into a bridge between quantum possibility and experienced reality. That is the central theme. Pilot wave theory preserves hidden trajectories. Born-Hilborn explains selected histories. We select history with quantum collapse. A hidden trajectory is not enough. Too much paradox. Too much error. A particle path does not explain consciousness. A particle path does not explain memory. A particle path does not explain sex drive. A particle path does not explain teleological evolution. A particle path does not explain why the future seems to matter. A particle path does not explain why Schrodinger's cat requires not only a state but a complete compatible history. The Born-Hilborn rule does. That is why the phrase must be repeated. History selection, History, is Selected, and we need to remember that across all lifetimes. Education matters. Quantum mechanics is not crying out for linear determinism. QM ignores linear time. It wanted a history selection principle. The pilot wave interpretation says particles were always somewhere. Fine, but reality is not asking merely where was the particle. Reality is asking why did this entire coherent world become the one world we know and love instead of many? How does pilot wave explain which cat we find in Schrodinger's box? A playful cat or a less playful cat? Steinberg's dice rolls now? Born-Hilborn answers because quantum possibility was multiplied by expectations across space-time. Wigner and his friends added weighted observer collapse because the Born rule was completed by the Hilborn rule. This mathematics finishes quantum mechanics because collapse is not random interruption, because collapse is not deterministic bead surfing, because collapse is history selection. The electron does not need a secret diary of where it really went. The universe needs a rule for why one history becomes actual. The rule is Born-Hilborn. Pilot wave theory is not deep enough. It gives a deterministic backstage mechanism while leaving consciousness, memory, teleology, and future expectation outside the main explanatory engine. It converts quantum weirdness into non-local hidden machinery and then congratulates itself for restoring paths into the model. Born-Hilborn is more ambitious and more satisfying. It says the real object is not the path of a particle, but the selected space-time history. It says the observer is not the disposable spectator, but a weighted participant. It says the future is not nothing, but part of the block universe waiting structure. It says thought has pressure, memory has history, sex drive has future demand, and life has a teleological thumb collapsing direction. Pilot wave gives us weak measurements averaged. Born-Hilborn gives us reality, and that is why the more clever alternative is not to chase the electron like a tiny fugitive through a double slit. The clever alternative is to ask which history has been selected when it goes through the slit. What expectation weighted it, and why this one world became the world we know and love. Reality equals QM times spacetime expectations. Reality equals QM times spacetime expectations. Reality equals QM times spacetime expectations. The end. If you understand the equation, then we should teach it to your fellow humans. Be blessed. Blessed be.